In this picture, you are given two angles that are on a line which is equal to 180 degrees. When we add these two angles together and equal them to 180 degrees, we can solve for x. 30 and negative 50 add together to give you negative 20. So you're left with 2x minus 20 equals 180. Add 20 to both sides and you're left with 2x equals 200. Divide 2 on both sides and you're left with x equals 100. The following is a word problem which we need to break up into pieces. We have one angle that is 12 more. 12 more means add 12. Then twice, meaning 2 times. Its supplement, meaning 180 degrees. Find both angles. If we make angle 1 equal x, we can manipulate angle 2 to be what the given word problem is. So twice gives us 2 times x, which is angle 1, and then we do 12 more, which is add 12. These two angles are supplementary, meaning we can add them together to equal 180 degrees. We add angle 1 and angle 2 to give us x plus 2x plus 12 equals 180 degrees. X plus 2x is 3x. Then we subtract 12 on both sides and give 3x equals 168 degrees. Divide 3 on both sides and you get x equals 56. However, we are not done. We need to substitute x into both angle 1 and angle 2. Angle 1 is just x, so we substitute 56 in for x, giving us angle 1 equals 56 degrees. Substitute x in for 2x plus 12, and you are given 2 times 56 plus 12 equals 124 degrees. So angle 2 is 124 degrees. In this problem, you are given a 90-degree angle. X plus 5 and 2x minus 10 add together to give 90 degrees. X and 2x add together to give you 3x, and positive 5 and negative 10 add to give you negative 5. These are still equal to 90 degrees. Add 5 to both sides, giving you 3x equals 95. Divide by 3 on both sides, and you are given x equals 31.67. In this problem, you are given two angles that are complementary. Complementary means equal to 90 degrees. 3x plus 10 and 2x minus 5 add together to equal 90 degrees. We can add 3x and 2x to give us 5x, and 10 and negative 5 to give us positive 5. Subtract 5 on both sides, and you are given 5x equals 85. Divide by 5 on both sides, giving you x equals 17. In this picture, you are given two lines that intersect, and also an angle on top and an angle on bottom. We call these vertical angles, and vertical angles are congruent. To solve two angles that are congruent, we can set them equal to each other, giving us 4x plus 12 equals 100. Subtract 12 on both sides, and you are left with 4x equals 88. Divide by 4 on both sides, giving you x equals 22. In this picture, you are given a set of vertical angles. X plus 50 and 2x minus 20 are vertical angles, meaning they are congruent. If we set x plus 50 equal to 2x minus 20, we can solve for x. Subtract x on both sides, leaving 50 on one side equal to x minus 20. Then we add 20 to both sides, giving us 20 equals x. In this picture, we are given two parallel lines intersected by a transversal line. 6x plus 1 and 14x minus 1 are called consecutive interior angles, also called same side interior angles. These two angles together are supplementary, meaning they are equal to 180 degrees. If we add 6x plus 1 to 14x minus 1 and set it equal to 180 degrees, we can solve for x. The positive 1 and the negative 1 equals 0. 6x plus 14x adds together to equal 20x. So we are given 20x equals 180 degrees. We can divide by 20 on both sides, giving us x equals 9. We are given two parallel lines intersected by a transversal line. 93 degrees and 5 plus 22x are called alternate interior angles. These angles are congruent, so 93 degrees is equal to 5 plus 22x. When we subtract 5 on both sides, we are given 88 equals 22x. When we divide 22 on both sides, we are left with 4 is x. We are given two parallel lines intersected by a transversal line. 70 degrees and 14x minus 2 are called alternate exterior angles. These angles are congruent, so we can set 70 degrees equal to 14x minus 2. When we add 2 on both sides, we get 72 equals 14x. Then we can divide 14 on both sides to get x by itself, giving us 5.14 equals x. We are given two parallel lines intersected by a transversal line. 17x plus 6 and 125 degrees are called corresponding angles. These angles are congruent. We can set 125 equal to 17x plus 6 and solve for x. We subtract 6 on both sides, giving us 119 equal to 17x. When we divide by 17 on both sides to get x by itself, we are given 7 equals x. In this problem, you are given a triangle. If you look on both sides of the triangle, you can see the line DE bisects side AB and side AC. Line DE is also parallel to side BC. We call line DE a midsegment of a triangle. Midsegments are half the length of the side that it's parallel to. So, since DE is parallel to BC, 2x minus 6 is going to be half of 104. So if we set 2x minus 6 equal to half 104, we can solve for x. Half of 104 is 52 degrees. Then we can add 6 on both sides, giving us 2x equals 58. When we divide 2 on both sides, we are left with x equals 29. In this problem, you are given a triangle with a line through the middle. You can see that the line bisects both sides into two equal parts. Because it does this, line 5x is going to be half of line 8x plus 10. So we can set 5x equal to 1/2 8x plus 10. Because 8x and 10 do not add together, we have to distribute the 1/2, giving us 5x equals 4x plus 5. When we subtract 4x on both sides, we are given x equals 5. Because the triangles, the small triangle and the big triangle, are proportional to each other, we can say that y is equal to 40 degrees. We are given a triangle with a line through it. Line ST is parallel to line QR. Because these two lines are parallel, line ST breaks our triangle up into two equal proportions. So therefore, we can set up a proportion. We can do small triangle over big triangle equals small triangle over big triangle, or vice versa. So we get 6 over 8, because 6 and 2 add to get 8, equal to 9 over 9 plus x. We cross multiply and get 6 times 9 plus x equal to 9 times 8. Because 9 and x cannot add together, we have to distribute the 6 to both the 9 and the x, giving us 54 plus 6x equals 72. We subtract 54 on both sides, giving us 6x equals 18. Divide 6 on both sides, and you are given x equals 3. You are given a triangle with a line going through it. That line is parallel to one side of the triangle. Because these two are parallel, the line through the middle breaks the sides of our triangle up into two proportional parts. We can do small triangle over big triangle equal to small triangle over big triangle, and vice versa. Then we set up our proportion. So 15 over 39, which comes from 15 plus 24, equal to 10 over x. Then we cross multiply. We get 15 times x equal to 39 times 10, giving us 15x equals 390. We divide both sides by 15 on both sides and get x equals 26. You are given a triangle with 2 out of 3 angles. We know that 95, 35, and x add together to get 180 degrees because the sum of the interior angles in a triangle is 180 degrees. So if we add 95 plus 35 plus x and set them equal to 180 degrees, we can figure out what x is. 95 plus 35 gives you 130. Then you subtract 130 on both sides and you are given x equals 50. In this problem you are given a right triangle. The box in the corner means 90 degrees. The sum of the interior angles in a triangle is 180 degrees. So we can add 3x plus 5x minus 14 plus 90 and set it equal to 180 degrees. 3x plus 5x adds together to give you 8x. 90 plus a negative 14 adds to give you 76. We can subtract 76 on both sides, and we are given 8x equals 104. Then we divide 8 on both sides, and we are given x equals 13. In this picture, you are given a triangle, giving you two interior angles with an exterior angle. Exterior angles equal the sum of the two remote interior angles. So we can add x equal to 21 plus 34. 21 and 34 add together to give you x equals 55. You are given a triangle with two interior angles and a remote exterior angle. Exterior angles equal the sum of the two remote interior angles. Therefore, 3x minus 10 is equal to the sum of 25 and x plus 15. We can add 25 and 15 to give us 40. Then we subtract x on both sides, giving us 2x minus 10 equals 40. When we add 10 to both sides, we get 2x equals 50, and then divide 2 on both sides, giving us x equals 25 degrees. In this picture, you are given an isosceles triangle. An isosceles triangle has two congruent sides with two congruent base angles. If the sides of a triangle are congruent, then their base angles are congruent. So if one of our base angles is 50 degrees, the other one is automatically 50 degrees. The sum of the interior angles in a triangle is 180 degrees. So if we take 180 and subtract 50 2 times, we are left with 80 degrees for y. We are given a triangle with base angles congruent. If the base angles of a triangle are congruent, then their sides are congruent, making this an isosceles triangle. So 16 and y plus 4 are congruent. When we set them equal to each other, we can subtract 4 on both sides, giving us 12 equals y. In this problem, you are to name the corresponding parts of the triangles. You are given triangle ABC is congruent to triangle FEG. All we do is match up the letters. So in the first triangle, you use the last letter, then the first one. So we do the same thing in triangle FEG. So we use the last letter and the first letter, giving you line GF. In this problem, you are to name the corresponding parts of triangles. you are given triangle ABC is congruent to triangle FEG. The first that you're given is angle GEF, which is the triangle's letters going backwards. So the corresponding angle that goes with angle GEF is also going backwards in triangle ABC, giving you angle CBA. In this problem, you are to determine if the two triangles are congruent. You are given that the base sides of the triangles are congruent and that the base angles touching each other are also congruent. We know that the sides that are touching both triangles are congruent due to the reflexive property. So if we label these in order, we get side, angle, side. So these two triangles are congruent by side, angle, side. In this problem, you are to determine if the two triangles are congruent. You are given that two sides of both triangles are congruent. We also know that the other side is congruent due to the reflexive property. So if we label our parts that are congruent in order, we are given side, side, side. So these two triangles are congruent by side, side, side. We are given a triangle graphed on a coordinate plane. When we find the vertices, which are the corner points of the triangle, we get negative 5, 2, 2, 2, and 4, negative 3. It asks us that the dilation is 1/2. So if we multiply these vertices by 1/2, we get negative 5, 2 to be negative 2.5, 1. 2, 2 to be 1, 1, and 4, negative 3 to be 2, negative 1.5. We can assume that the center of dilation is at the origin because it is not stated. Therefore, we just plot these new points, negative 2.5 and 1, 1, 1, and 2 and negative 1.5 to give us our new dilation. We are given a quadrilateral graphed on a coordinate plane. It tells us that our scale factor is 2. So when we find the vertices of our quadrilateral, which is the corner points, we get negative 2, 1, negative 2, negative 1, 2, negative 2, and 2, 2. Because the center of dilation is not stated, we can assume that the center of dilation is at the origin. So when we multiply our vertices by 2, we can plot negative 4, 2, negative 4, negative 2, 4, negative 4, and 4, 4 on our coordinate plane to get our new dilation. In this problem, we are to find the missing sides for the similar figures. You are given two triangles. All we have to do is set up a proportion. 5 and 3 equal to s over 4.5. When we cross multiply, we get 3 times s equal to 5 times 4.5, giving us 3x equals 22.5. When we divide 3 on both sides, we get s equal to 7.5. In this problem, we are to find the missing sides for the similar figures. We match up the sides that go together and set up a proportion. 6 and x go together, so we make that a fraction, as well as 8 and 12.8. Then we cross multiply, getting x times 8 equal to 6 times 12.8, leaving us 8x equals 76.8. When we divide 8 on both sides, we get x equals 9.6. We are to find the missing sides for the similar figures. We have a small triangle on top of a big triangle. The sides for the small triangle is 4 and x, and the sides of the big triangle is 4 plus 7, which is 11, and x and 12, giving us 12 plus x. All we do is set up proportions. Small triangle over big triangle equal to small triangle over big triangle, or vice versa. We set 4 over 11 equal to x over 12 plus 6. Then we cross multiply. 4 times 12 plus x equal to 11 times x, giving us 11x equals 4 distributed into 12 and x, giving us 48 plus 4x. We subtract 4x on both sides, giving us 7x equals 48. Then we divide by 7 on both sides, giving us x equals 6.86. In this problem, you are given two triangles, a small triangle on top of a big triangle. All we have to do is set up a proportion. Small triangle over big triangle equal to small triangle over big triangle, or vice versa. 2 and x go together, as well as 5 over 10 plus 5, which is 15. Then we cross multiply. We get 5 times x, which is 5x, and 2 times 15, which is 30. We divide both sides by 5, giving us x equals 6. In this problem, we are to determine if the two triangles are similar, and then write the similarity statement. All you are given are sides, so we set up our proportions. Side GN and side AL go together. So when we do 20 over 15, we get 4/3. Then we do side HL and side GK, which is 12 over 9, and again we get 4/3. Then we have side AH and side NK, which is side 8 over 6, which gives us 4/3. Since all three sides have the same proportion, which is 4/3, we can say that these two triangles are similar. In the labeling, we get triangle G and K. So the parts that label up with G and K is LAH. So we can say triangle G and K is similar to triangle LAH by side, side, side. In this problem, we are to determine if the two triangles are similar, and then again write the similarity statement. We are given two angles and a side. Angle A and angle Y are both 75 degrees, and angle C and angle Z are both 65 degrees. Because they have two angles that are congruent, we know that these two triangles are congruent by angle, angle. The first triangle is labeled ABC. So we match the corresponding sides and we get triangle ABC is similar to triangle YXZ.